So when we apply the Leibniz theorem, we'll get in the form 1 plus x square yn plus 2 plus 2n plus 1 x yn plus 1 plus n square yn equal to 0. Now we need yn at 0. So put x equal to 0. So that gives yn plus 2 at 0. The second term will become 0. It will be equal to minus n square yn at 0. So here we have a recurrent relation. Now let us find out the starting values. So when we take y at 0 will be, we will get log 1 will be equal to 0, and for y1 will be equal to 1 varum, y1 at 0 is 1, and from the expression for y2, so y2 at 0 is equal to 0. So these are the initial values we have, and we have the recurrence relation yn plus 2 at 0 is equal to minus n square yn at 0. So let us find the values. Okay, so when n is equal to 1, so we will get y3 at 0. So y3 will be in terms of y1, so that will be minus y1 of 0, so that will be equal to minus 1 varum. Then y4 of 0, so that is when n is equal to 2. Y4 of 0 will be equal to, that will be in terms of y2 of 0, so that will be equal to 0. And when n is equal to 3, we have y5 of 0, so y5 of 0 will be minus 3 square into y3 of 0. y3 of 0 is minus 1, and then you have n equal to 4, so we have y6 of 0, again y6 of 0 will be in terms of y4, that is again 0. So we can write y1 as 1, then y3 we can write as minus 1 square, then y5 will be minus 1 whole square into 1 square into 3 square. Ini namukku y7 varum, let us look at that also. So y7 of 0 when n is 5, so that is minus 5 square y5 of 0, so that is again minus 1 whole square, 1 square, 3 square, so that is minus 1 whole cube, 1 square, 3 square into 5 square. So this is the form in which we are getting. So even values will be 0 and the odd values will be taking this form. So therefore we can now write the general expression for yn at 0 where n can be either even or odd. So when n is even, the value of yn will be equal to 0, and when n is odd, so we will have minus 1 whole power, so we will have n minus 1 by 2, 1 square into 3 square into 5 square into up to n minus 2 whole square vare aayirikkum vara, n is odd. So that is the required value of the nth derivative. Please work out this problem also on finding the nth derivative at x equal to 0. So ആദ്യം first derivative and second derivative കണ്ടുപിടിക്കുക, then apply the Leibniz theorem from that in the general expression. In this expression substitute x equal to 0. So using the recurrent relation obtain the value of the nth derivative. So please solve this problem.